Okay, so we just figured out that we've got these plates and they're 1 millimeter apart. And we've got this much charge on them, right? That the voltage across it is 216.9 volts if it's 1 millimeter, right? The voltage is 216.9 volts for that much charge, and the energy stored is 1.3 times 10 to the minus fifth joules, right? So now we're going to take those plates and we're going to separate them by 3 millimeters, right? Which would be about like this. Same area. Keep everything the same, right? We're just going to separate them. And we're going to get, of course, when they're separated farther, it'll be less capacitance, right? But the voltage could be higher, right? So let's look at that, okay? So if it's 3 millimeters apart, the capacitance is 8.85 times 10 to the minus 12th times 0.25 times 0.25 over 0.003, right? So let's do that. Let's find that. There. 0.003. And now our capacitance is 1.843 times 10 to the minus 10th farads. All right. So now we've got our capacitance. Let's figure out our voltage, right? Voltage is going to be charge over capacitance. So that's going to be 0.12 times 10 to the minus 6th divided by 1.843 e minus 10. So divided by the number we just got. Ooh, that's a lot more voltage. The voltage across this capacitor is 650.8. So this is an interesting thing, right? Here the voltage is 219.6. When we separate them a little bit, the voltage would increase. And in fact, you can do this. This is a physics demonstration. You can take a capacitor, charge it, and then slide the plates apart, and the voltage will go up. And the reason that the voltage goes up is that the voltage is the work divided by the charge. And you simply have done work on the charge by separating the plates. You've moved them apart. The work of doing that goes up. The voltage goes up. That's kind of fun. All right. So now the potential energy stored on it is 1/2 CV squared. So it's going to be 1/2 times 1.843 times 10 to the minus 10th times 650.8 squared. Okay, so I'm going to go 0.5 times the capacitance times the voltage. Don't forget to square the voltage. Don't forget to square. And I'm getting that energy is 3.9 times 10 to the minus 5th joules, which is kind of fun. It's sort of fun. It's like 3 times what it originally was, okay? Because we moved it 3 times farther. Yeah, all right.